Alright guys, so we're gonna start chapter 4 or lesson 4.1 in this video here. I'm gonna try and break this section into several videos. It's a long sections, but I don't want to spend more than 10 minutes talking in each video. So what is this lesson about is we're gonna discuss further concept more in depth regarding the first derivative. So what this means is just, what does this f prime of x, what does that means? What does this tell us about f of x? So that's the goal of this lesson, to have a visual understanding what this means, and also an actual understanding how to describe that through math, problems or just calculations. So let's start with a function here. So suppose we have a function. Suppose we have a function f of x is equal to x to the third minus 3x. Okay, we know how to find the derivative f prime of x. So first derivative means the first time you take the derivative of the function, using the power rule. In this case, it's going to be 3x squared minus 3x. Excuse 3. So what we want to find out is, what is this f prime of x function is telling us about the function f of x itself. Okay, so we already know this here, and I'm just going to restate it. We already know that f prime of x tell us about the slope of the tangent line to f of x at certain point on the graph. Okay, all right. But what we really want to find out is, in general, okay, what does that say about the values of f of x? And that's the goal there. Okay, we want to answer that question. So to understand that a little more better, let's pull up the graph of x to the third minus 3x. And I've already graphed this and screenshot it already. I'm going to go ahead and move that down here. I'm going to go ahead and move that graph down here. Here it is. Zoom in. All right. Zoom out a little bit. Okay. So here is the graph of f of x equal to, so this is f of x equal to 3x to the third. No, I think it's x to the third. Let me go ahead and erase this here. Let's try that again. This is f of x equal x to the third minus 3x. Okay, and we know that the derivative is 3x squared minus 3. Okay. So let's pick a point on the graph here. Suppose I want to pick a point. Let's say here is the point. So it looks like this point here has a coordinate of, let's say that is about negative 1.5. I'm going to say negative 1.5 comma 1. So let's say comma 1. So that's the point there. Okay. So let's draw the tangent line to that point. So let's use different color here. Let's use this color, purple. So this is the slope of the tangent line to the graph at that point. And let's look at another point on the graph. Okay, let's look at this point here. Okay, and let's draw the slope of tangent line. Okay, so if you remember from algebra, if the slope start from low to high, I mean, it's looking at this way here. This means the slope is positive. Okay, so this is indication of positive slope, if you remember that from math 120. And I want us to take a minute and look at the y values correspond to each of those points. Okay, so here is the y value for that point, and then here is the y value for that point. So we go from 1 to maybe 1.8, for example. So if it's positive slope, okay, and the slope is indicated by f prime of x, okay, So at each of those points, we can calculate what is that f prime of x, what is that positive slope. And it turns out that it's going to be greater than 0. Positive slope means greater than 0, by the way, guys. So if the slopes are positive, as you see here, all right, the y value go from here to there. So what does that mean? That means the function values, the y values, so we say y values, or f of x, is increasing. Okay. That's what happened there, as the f prime of x is positive value, or the slope themselves positive. Now let's look at the case where the tangent slope are not positive, but it's negative. Okay, so I want to pick another point here. Let's say we pick this point and compare it to this point here. So let's say that point has a maybe 0.2 and 1 negative of that, and down here let's say this is a 0.2 comma negative 1. Let's draw the slope of tangent line here. So we got the slope of tangent line, so that's going to be a negative slope. You remember from Math 120 there, and then even down here is also negative as well. Okay, so these are we're going to say that these are negative tangent slope. Okay, and that means f prime of x less than 0. Okay. All right. Now let's look at that in terms of the values of f of x. Okay, what's the indication of the value of f of x? So here is the value of the y there, and then since we have a negative tangent slope, the y value is down here. So it looks like the y values are decreasing. Okay, meaning that if f prime of x are negative, meaning less than 0, then the function values are decreasing, or f of x is decreasing. Okay, so decreasing, I think I spelled that wrong. Let's go ahead and summarize that. Okay. All right, so from the picture we have this. Okay, from the picture of the graph we have this. Okay, all right, if the slope of tangent line, or if f prime of x is greater than 0, meaning the slope of tangent line, so slope of tangent line is positive. Okay, that's what I mean. Then the function values are increasing. Okay, and if f prime of x is less than 0, then f of x, or the function values, are decreasing. Okay, that's what we got from the picture there. Okay, but I want to define a little more formally, what does it mean for a function to be increasing, decreasing in terms of math notation. Okay, so we say that f is increasing over an interval AB. Okay, if we have the following: if f of x2 is greater than f of x1, whenever we have this, x1 is less than x2 and less than b, meaning any two values within the interval AB, okay, x1 and x2, the function value corresponds to those x, or the output. Okay, one is greater than the other one as the x increasing, so they're saying that as x increases, f of x also increases. That's what it's saying. Okay. So that is just a brief introduction about increasing, decreasing functions, and what the derivative is telling us. Whereas the first derivative is telling us, is saying that if we compute the tangent slope, or if the derivative is positive at a certain value of x, then the function values are increasing, and if the derivative is less than 0, then the function values are decreasing. Okay. The next video, we're going to talk about how do we tie that to a critical values, or a point where the derivative themselves are neither increasing nor decreasing, and we've already done this a lot of times. Those are these values here. Okay, if we draw a tangent line at this position, notice that the slope of tangent line there is not positive or negative, it's actually 0. Okay, and there's a name for the value of x that make this happen. We're going to talk about in the next video critical values.